Did you know the average lifespan of a light bulb is 1,000 hours? That's a lot of bright ideas. In this world where darkness and light constantly dance, light bulbs play a crucial role. They're our silent companions, guiding us through the night and brightening our days. But have you ever stopped to wonder how these tiny beacons of light are created? Well, you're in for a treat. In this video, we're going to pull back the curtain on the intriguing process of light bulb creation. From the birth of a bulb to the final testing stage, we'll unveil each step that transforms a simple idea into a shining reality. And guess what? Along the way, we'll even share some fun facts. For instance, did you know that the filament inside a bulb can reach temperatures up to 4,000 degrees Fahrenheit? Fascinating, isn't it? So buckle up as we illuminate the process of light bulb creation. Our journey begins with the bulb's heart, the tungsten filament. This filament is more than just a thin wire. It's the result of a fascinating process that begins deep within the earth. Tungsten, the metal we use to make these filaments, is extracted from underground mines. It's a hard, steel-grey metal that's incredibly dense. It's so dense, in fact, that it's about 1.5 times heavier than lead. The extracted tungsten is then processed into a fine powder. This powder is mixed with other elements to create a compound that's easier to work with. Once this compound is ready, it's heated to a very high temperature. This process, known as sintering, changes the compound's structure and makes it much stronger and more durable. But we're not done yet. The sintered tungsten compound is then drawn out into a thin wire. This process is quite a feat, considering that tungsten is one of the hardest metals on Earth. It takes a lot of force to draw the tungsten out, but the result is worth it. A thin, strong wire that's ready to light up our world. Now, you might be wondering why we go through all this trouble for a tiny piece of wire. Well, tungsten has a special property that makes it ideal for light bulbs. It has the highest melting point of all metals. In fact, it can withstand temperatures as high as 6,192 degrees Fahrenheit. That's hotter than the surface of the sun. This incredible heat resistance is what allows the filament to glow white hot without melting or breaking. When electricity passes through the filament, it heats up and emits light. And thanks to tungsten's high melting point, the filament can do this over and over again, providing us with light whenever we need it. With the filament ready, we move on to the next step. Now imagine a house made entirely of glass. That's the bulb part of our light bulb. This is where we dive deep into the creation of the glass bulb, the transparent home for the glowing filament inside. The making of a glass bulb is a fascinating process that starts with a humble beginning: sand. Yes, the same sand you might find at the beach. This sand, mostly composed of silicon dioxide, is heated to incredibly high temperatures, around 3,000 degrees Fahrenheit. The heat is so intense that it causes the sand to melt, transforming into a fiery liquid state. This molten mass is the raw, unformed glass. Once in this liquid state, the glass is ready to be shaped. This is where the artistry comes in. A skilled glass blower takes a hollow metal tube, dips it into the molten glass, and collects a small gob at the end. This blob of molten glass is then blown into the iconic shape of a light bulb. It's a dance of heat and precision, with the glass blower controlling the size and thickness of the bulb through their breath and subtle movements. Following the shaping process, the bulb must cool down slowly in a process called annealing. This step is crucial to relieve any internal stress created during the blowing process and to ensure the bulb is strong enough to withstand the pressure changes it will face during its lifetime. But let's not forget about the top of our glass house, the tip of the bulb. This is made separately using the same glass blowing process and then fused to the main body of the bulb. This creates a sealed environment, ready to house the filament and the inert gas we will introduce later. And there you have it. From grains of sand to a delicate glass bulb, the transformation is nothing short of alchemical. The glass house is ready, but we are not done yet. Ever wondered why light bulbs don't just burn out instantly? The answer is they're filled with inert gas. Yes, you heard it right. Inert gas plays a crucial role in the longevity of our everyday light bulbs. But why is that, you ask? Let's dive into the science behind it. In the world of light bulbs, the filament, a delicate wire that glows when electricity passes through it, is the star of the show. However, without the supporting actor, the inert gas, our star would quickly burn out and break down. In most cases, the inert gas used is argon. It's colourless, odourless, and as the term inert suggests, it doesn't react chemically with the filament. This lack of reactivity is essential in preserving the filament's integrity and prolonging its life. Imagine you left a piece of bread in the open. It would soon go stale, right? This happens because the bread reacts with the oxygen in the air, causing it to spoil. Now think of the filament as the slice of bread. If the filament were exposed to regular air, the oxygen would cause it to deteriorate rapidly. But by filling the bulb with inert argon, we essentially create a protective bubble around the filament, preventing such a reaction. So, how does this gas make its way into the bulb? In the manufacturing process, after the filament is secured inside the glass envelope, the bulb is evacuated, creating a vacuum. This vacuum is then filled with argon. This process ensures that the only gas inside the bulb is the inert argon, providing the perfect environment for the filament to shine bright and long. It's fascinating, isn't it? How a seemingly simple object like a light bulb is actually a product of such intricate science. Every component, including the invisible argon gas, plays a vital role in its functioning. With the gas in place, we're ready for the final steps. Stay tuned to discover more about the fascinating journey of a light bulb's creation. We're now at the home stretch. Our bulb needs a base, and it needs testing. Now you might be wondering, why does a bulb need a base? Well, the base of a light bulb serves a dual purpose. Firstly, it connects the electrical contact of the light bulb to the power supply. Secondly, it physically secures the bulb in its socket. Quite essential, wouldn't you agree? To create this, a metal base is shaped and attached to the bulb. The base is crafted so that it ensures a secure fit, firmly cradling the glass envelope. It's a delicate process, balancing the need for a snug fit while ensuring the glass bulb isn't damaged. Once the base is attached, the next step is the testing phase. This is where the bulbs are checked for quality and longevity. It's the kind of quality control we all appreciate, ensuring our bulbs don't give up the ghost just when we're settling in for a cozy evening with a good book. Each bulb is put through a series of rigorous tests. They're turned on and off multiple times to mimic the average use of a household light bulb. This is to ensure they can survive the rigors of daily life. They're also tested for brightness, to ensure they deliver the right amount of light. After all, no one wants a dim bulb when they're trying to illuminate their world, right? And of course, the bulbs are tested for longevity. This usually involves leaving them on for an extended period to see how long they last. This is crucial because a bulb that burns out too quickly is a disappointment to everyone. But here's a fun fact for you. Did you know that the longest burning light bulb in the world has been on for over 100 years? It's known as the Centennial Light, located in Livermore, California. Now, that's a bulb that passed its longevity test with flying colours. And there you have it. Our light bulb is ready to shine. We've journeyed from tungsten to inert gas, from glass house to metal base. We've seen the birth of a bulb and witnessed the meticulous process that goes into creating these tiny beacons of light. From a simple piece of wire, we've watched it transform into a glowing filament, encased in a delicate glass shell, filled with an inert gas to prolong its life, and finally, attached to a metal base to connect it to the power source. Now, how about a fun fact or two? Did you know the longest burning light bulb, affectionately known as the Centennial Light, has been shining for over 100 years? Located in Livermore, California, it's a testament to the enduring power of the humble light bulb. And here's another one. The first light bulbs used bamboo filaments. We hope you've enjoyed this enlightening journey into the world of light bulbs. Until next time, keep shining.